So hello and welcome to the walkthrough series. In this episode, we are looking at the Java version or the Java solutions to the November 2021 variant 4.1 paper. So let's go ahead and jump to number 1 and see how you can actually go about answering the paper. So start with the following pseudocode for a recursive function. We are given a pseudocode algorithm right here for a function called unknown, which is taking two arguments, x and y of type integer, then it's going to return an integer. So essentially we are supposed to implement this pseudocode in Java, right? So the way we can go about it, right here on the left side of my screen, you can see, let me just zoom in a little bit. We have the implementation of this pseudocode equivalent. So yes, this is the Java equivalent for that code. So as with everything in Java, whenever you're going to write your code in Java, it's always going to belong inside of a class. So on line number 3 there we have our class definition, and the name of our class is called question1, and you can see that the question1 name that we have right here for the class, it's also the same as the file name that we have for our Java file. So you need to remember that the file name should always be the same as the class name in Java. Then for the function header, we are declaring a function called unknown, and it's going to take two arguments, or it's going to take two parameters, and it's going to return an integer. So the way to do that in Java is to declare it public, then static. Static simply means that this function is going to belong to the class, right? Or in other words, we don't need to instantiate an object to make use of this particular method. So that's why we've made it static in that instance. Then here we have int, which is the return type. Integer, because remember this function is going to return an integer. So in Java you have to specify the return type in the function header like this. Then the name of the function is called unknown. So here we have unknown, and it's going to take two arguments of type integer. So you need to remember that in Java, if you are going to take two arguments, even if they are of the same type, like in this particular instance they are both integers, we simply have to make use of rather each variable, like x and y in this instance, they should have their own type declaration individually. So you cannot bunch, or you cannot bundle type declarations in Java. So let's suppose that we were going to have another third variable, or another a third parameter called z or z. So that would mean that you need to have another declaration for int z, like much like so. Alright, so that's how you'd have gone about it. If in the event that we needed three type declarations or three parameter declarations. Then moving on to line 6, that is the if statement we have going on in our pseudocode right there. So this if x is less than y, that's what we are doing there. Then we open our curly braces for the body of the if statement. Then if x is less than y, we first want to output x plus y, which is what we are doing right there. So in this particular instance we are using this out.println shortcut, because what we did on line 1 there is that we did import the system class, is it? So since we've imported the system class, it simply means that we can then go ahead, instead of having to type system.out, we can simply go and say out.println then x plus y. Then we are supposed to return unknown, then x plus 1 rather, comma y multiplied by 2. So that's what we are doing there on line 8. Then we have that else going on in the pseudocode, and we also have that else in our Java code right there. So you see that we are saying if x is equal to y, then we need to return 1. Otherwise we need to output x plus y. Then we need to call unknown, but this time around we are going to call unknown with x minus 1 y, then dividing by 2. So you need to remember that for integer division in Java, if you just use this the forward slash, it's going to perform integer division. In essence, it's going to, when you have two integers, it's going to truncate, or it's going to discard of the decimal part. So that's how we go about it. Then that's the end of the function. So here the question is, it asked us to implement this as program code. So this is what we did here, and for that you are going to get 3 marks for translating this pseudocode into that program code in Java. So let's move ahead and look at B. So the main program needs to run all 3 of the following function calls and output the result. So in other words, we simply need to call the unknown function or the unknown method 3 times, passing those arguments of 10, 15, 10, 10, then 15 and 10. Then for each of the 3 function calls, the main program needs to output the value of the 2 parameters, call the function with those 2 parameters, output the returned value. So let's go ahead and expand the code for the main method right here. So what we are doing is we need to output the value of the 2 parameters. So what we are doing in this case is the 2 parameters in the first instance are 10 and 15. So what we can do is just outputting, or rather displaying a message down in the console which says that we are calling unknown with 10 and 15 as the parameters, right? Then we need to call the function with those parameters. So on line number 22, we are now calling unknown with 10 and 15 as the parameters. Then output the return value. So once we call it in this instance, we are going ahead to, we are moving on to outputting the return value. So that's what we are doing in line 22. So in essence, line 22 is achieving 2 things. It's calling the unknown method, at the same time it's outputting the value of the unknown method, the value that would have been returned by the unknown method. So it says here that we need to write the program for this, the program code for the main method, which is what we did right here from between lines 20 up to 26. Then we need to copy and paste this source code into the main or into the evidence document, so that you go ahead and copy this code and paste it inside of the evidence document. Then B item 2, it's saying that take a screenshot to show the output from B part 1. So for B part 1, we are going to need to run this. So let me just go ahead and click and run my code right here. Just give it a minute so that it populates the terminal. So you see that this is the output. This right here is the output. So calling unknown with 10 and 15, we are going to get these values. Then calling unknown with 10 and 10, we are going to get just a single output, which is 1. Then calling unknown with 10 and 15, we are going to get this output right here, 25, 24, 23, 22, 21, then finally 0. So you are going to, this is where you would actually take a screenshot of your output and paste it in the evidence document. Then moving on to part C, rewrite the function unknown as an iterative function. And we are going to want to call it iterative unknown. Then save your program. Let's move on to look at iterative. So let me just expand down here. So essentially, whenever you see iterative, whenever you're implementing a function or a method iteratively, it simply means that you are going to make use of a loop, as it were. So in this particular instance, my loop of choice, I'm using the while loop, and essentially I'm initializing again. If you look at the function header, it's still the same thing, right? Except that the function name is now different. We're now using iterative unknown, then, but still we are also taking 2 parameters of type x and y. Then the total is going to be equal to, initialize the total to 1. Why are we initializing the total to 1? Because you'd remember that if you come back to the unknown function right here, you realize that if x is equal to y, we need to return 1. So initially we need to have a return value that we can give in the event that both x and y are equal to 1. So if x and y are equal to 1, then we simply return total. That's why we are setting total to 1. But otherwise, we want to check if x is not equal to y, right? So if x is not equal to y, then it means that we are going to go ahead and output this code. So what we first want to do is to output x plus y. Then we check to see if x is less than y. So if x is less than y, it means that we need to increment x by 1. Then we now assign a new value for total. So we're now saying the current value of total times 2. Then we say that is the new total. Otherwise, we're going to decrement x by 1. Then we divide the total by 2. So essentially, that's how you can implement this, the functionality that we saw in this pseudocode. That's how you can implement it iteratively. Then for part D, so having written this code between lines 42 and lines 56, you then copy this code and paste it in the evidence document. Then part D, it says that the iterative function needs to be called 3 times the same parameters as in part B. Then for each of the 3 function calls, the main program needs to output the value of the 2 parameters, call the iterative function with those parameters, then output the 10 value. Again, this is pretty much the same thing that we did earlier on with this with the unknown method there. So we just want to do the same thing with iterative unknown. So coming back to the main method, right, this is where we have this comment right here, which is saying that now we are using iterative unknown. So we are basically doing the same thing, but this time around we are calling with iterative unknown. So let me just go ahead and run that code. So you see that right here we are saying now we are doing the same thing, but now we are now calling with iterative unknown. So the parameters that we are passing are 10 and 15. So you realize that this output is actually going to match the output for the unknown function, which was being implemented. It was being implemented recursively. Is it? This one was using recursion. This one was is using iteration. So again, it's still the same thing going on here. It's the same output as before. Then this is the same output as before. So you go ahead and take a screenshot of this. Then you paste it in your evidence document. Then moving on to part D item 2, we've pasted the screenshot. Yeah, I think that does it for number 1. So that's how you can actually go about it. So I would encourage you to go through the code. Actually, you can even attempt it on your own before you can follow along with the code in this video. Then I'll see you in the video for number 2.